Good morning. This is Geometry Lesson 1.5, and this is a video lesson, and it's a pre-recorded one. So this is actually going to cover material for IXL Lesson B11, which is the distance formula. And you're going to take notes on this, and remember that when you take your notes, you must put a header at the top of the first page of your notes for the day. Print your name, your full name, first and last name, your period, your date, and the subject. This is the subject, distance formula. And then you will take, of course, when you're done with the pictures of the pages, and you're going to send it to me by email no later than 11:59 p.m. Sunday, and this is my email address here. Remember that your notes are going to include what's on this outline. You might choose to also add some information that I'm orally telling you. I'm also annotating. I've actually annotated this previously because I had a different version that I presented to earlier students. Okay, so let's move on, and because now you have control of the recording and can start and stop it, I can turn the page at any time, but you can go back to the previous page if you have a question. All right, so you're going to be able to determine the distance between 2 points after you've reviewed this video using their XY coordinates and the distance formula. So 2 points, we're going to use the XY their XY coordinates, and we're going to use the distance formula. So here is the XY coordinate chart. I thought that it would be useful to show you what I'm talking about. So in geometry, the distance between 2 points is often measured by graphing the points on an X and Y coordinate chart. And so what I'm showing you here is you've got a line, a sloping line, and normally you cannot measure that very well. If you had a vertical line, you could just count the units for the y-axis and figure out what the length is of your line segment. If you had a horizontal line, you could do the same using the x-axis. But here, this line is sloped. So the only way you're going to solve that length issue is by using the distance formula. Okay, so the distance formula is used to determine the length of a line segment because it utilizes the XY coordinates of the two endpoints. And the distance formula actually, and I should put formula here, put a little caret there and put it up above. It's a little hard to see, but the distance formula is actually the Pythagorean theorem solved for one side of a triangle. Okay, and so, you know, going back here to the XY coordinate chart, you'll notice what I did here. I drew dashed lines that were vertical and horizontal from the 2 points, and then I had the meet up here. And if you do that, you form a triangle. So Pythagoras did not have the distance formula, but when the XY coordinate chart was created, the people who started using it realized that they could actually modify the Pythagorean theorem to come up with a distance formula for any of the sides of a triangle. So this is the distance formula. And you know, after they got to thinking about those same people that said, you know, I can use the distance formula for the sides of a triangle, then they said to themselves, wait a second, I can use it for any line based upon the fact that I can, as long as I have a straight line, I can create 2 more lines to create a triangle. So any line on an XY coordinate chart can be measured using the distance formula as long as you have its endpoints. So the distance formula is this rather complicated looking formula here, but it's not really. It's pretty simple. It's the square root of, and then we have in parentheses, x x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of it at the end. Okay? So we're going to do a problem and show you how that works. Here's our example. We're going to find the distance between the points 9 and 2 and 6, I'm sorry, between the points, the first one of which its xy coordinates is 9 and 2. So I've labeled those x1, x sub 1, and y sub 1. Okay? And then the second point has coordinates of 6 and 6. So I've labeled them x sub 2 and y sub 2. And what I'm going to do is I'm going to bring that information down and I'm going to write it here. So I'm going to write 9 comma 2, and 9 is going to be x sub 1 and 2 is going to be y sub 1. Okay, and then I'm going to put in parentheses 6 comma 6, and 6 is going to be x sub 2 and the other 6 is going to be, whoops, y sub 2. Okay. All right, so what I'm going to do is I'm going to populate the distance formula with these coordinates. So I'm going to split up the x's. I'm going to use this 6 here, the x2, and I'm going to put it in and replace this x2 here, and so on. So I'm going to rewrite the formula. Distance equals the square root of, and then I'm going to put in parentheses. Now I'm going to look for x sub 2. So here's x sub 1. Here's x sub 2. It's 6. So 6. And then it's minus. I'm going to put that in pencil for the moment. And then minus x sub 1. So x sub 1 is 9. And we're going to square that. And we're going to add it to y sub 2, so y sub 2 is over here, it's 6, and then I'm going to in pencil put the subtraction sign in the formula, and then y sub 1 is 2, and we're going to square that. Now to solve this, if you'll notice when we're looking at this, we already know that d is by itself, so actually essentially this formula is solved for distance. But just if you think of it where the variable is by itself, you don't have to think about it as being solved for, but that's what it is. Then what you're going to use to come up with your answer for what the distance is you're going to simplify, which means you're going to use the order of operations and in particular the order of operations is PEMDAS. Okay, so you're going to use PEMDAS, and that's this more simple. All right, parentheses, that's the first thing there. So we're going to go over here and in parentheses on the left we have 6 minus 9. Well, what is 6 minus 9? You may need a calculator for that. You're welcome to use one. I have mine right here, but 6 minus 9 is going to be, let's clear this. I'm going to type in 6, subtract 9, and I'm going to get -3 as my answer. So I'm going to write distance is, in parentheses, -3, and then squared, plus, now 6 minus 2, that one's pretty easy. 6 minus 2 is 4, so I'm not going to use the calculator for it. So we'll just put it in parentheses 2, 4 squared. All right. So now that we've done that, the next thing you would do is ignore the parentheses because there's just one unit in each of them. So go back to PEMDAS, and and start again. Parentheses we don't need, but exponents. Well, we have exponents here. So negative 3 squared. Well, negative 3 squared is negative 3 times negative 3, and negative times negative is positive. So it's going to be positive 9. You're welcome to use the calculator, but sometimes it screws up when we're dealing with negative times negative. So I'm just going to leave it for the moment. And we're going to put d equals the square root of 9 plus, and then square root of 4 is nothing more than 4 squared, or 4 times 4. 4 times 4 is 16. Okay? So we did the exponents. So exponents. And now we're going to add. So we're going to add what's under here, according to PEMDAS. So d equals the square root of 9 plus 16 is 25. Now, if you know what the square root of 25 is, that's great. But for those of you who don't, the wonderful thing about these graphing calculators, and scientific calculators for that matter, is they allow you to take the square root of something. With a graphing calculator, you have to use a button that has multiple uses. So you'll notice I have a blue second button up here, and I have a green alpha button. And then what that's meant to do is to change an ordinary button that says whatever it says on the top. So this one here says log. I'm going to bring it up here. Log, that's for logarithm. If I press that log button, it would say log at the top in parentheses. But if I'm going to clear that now. If I go here and click the second button at the top and then click the log button, it's going to say what it says in blue behind the log button. It's going to say 10 to some power, okay, 10 to the x, all right? And then if I click the alpha button, you would get an s, okay? So in this case, we're going to go to this x squared button, which is right here, and above it there is a square root sign in blue. So I'm going to click the second button, the blue second button, and I'm going to click the x squared button, and it creates a radical sign symbol, which is kind of a shortened version of this down here, right? And then parentheses, and then we're going to type in 25 and close the parentheses, and we're going to hit enter. And when we do that, we get 5. So the distance here is 5 units, okay? So that's all it is. It's simple to do. And so we're going to try, well, I went ahead and wrote what we did here on this next page. But there you see it. And since I already wrote it, we can move on. And we're going to do one last problem. So find the distance between the points, one of which has xy coordinates of x is 10 and 9 is y. So we're going to call the 10 x sub 1 and the y sub 1. And then over here, the second point has coordinates of 2 and 3. So I'm going to make that 2x sub 2, and the y, or the 3 is the y sub 2. All right, so now I'm going to do the same thing that we did before. Distance equals the square root of, so you need to write that formula out. So it's parentheses, x sub 2, and I'm going to again put this negative sign in pencil, and then x sub 1. I'm doing that because I want you to understand that, you know, if you end up with, let's say if your x sub 1 here was a 10, I would be putting, I have a negative sign and then a negative 10, and that would give you a negative number, and you'd have to know to change it to positive. So that's why I show the negative sign in pencil, to remind you of that. Okay, and then I'm going to add to that, so y sub 2, and then in pencil, negative y sub 1. Now I'm going to write over here again the 2 points coordinates, so they're next to our formula. makes it easier to track this stuff and not make an error. So 10 comma 9, that's x sub 1, y sub 1, and 2 comma 3 is x sub 2, y sub 2. Okay. All right. Distance equals, and so now we're going to go ahead and substitute. And so x sub 2 is 2. So 2 minus x sub 1, which is 10 squared, plus, and then y sub 2 is 3. 3 minus, and y sub 1 is 9 squared. Okay. And so then let's go ahead and, using PEMDAS, we would first simplify what's in parentheses. So square root of 2 minus 10, I'm just going to do that in my head, that's negative 8 squared, plus 3 minus 9 is negative 6 squared. Both of these are negative numbers in here, but remember, negative times a negative is a positive. So square root of this is, well, negative 8 times negative 8, that's negative times a negative, positive 64. And this is negative 6 times negative 6. So negative 6 times negative 6 is positive 36, because a negative times a negative is a positive. Lastly, well, not lastly, then you're going to, second to lastly, add together 64 and 36. You can do that with a calculator. It adds up to 100. And then to take the square root of 100, let's just use the calculator. We'll do the square root thing again like we did before. So we'll go to the second sign up here at the top. We'll go down here to the x squared button and click it. And then in parentheses, we're going to type 100. We're going to close the parentheses. We're going to hit enter, and we see that the distance is 10. Okay. So you now have it. This is everything that you need. And so with that, we're done, and I'll let you go. Take care.